It says, doesn't the emergence of dieback-resistant ash provide support for natural selection and evolution? The answer is no, because the resistant population was already there. All that you did is eliminate all the ones that weren't resistant and left the ones that were to be able to repopulate. So they haven't changed, they haven't evolved, they haven't designed something differently. They've literally already part of their genetics to be able to resist it. But I know, John, when it comes to things like bacteria and stuff, you can have mutated bacteria that do become resistant to things like antibiotics. Maybe Diane would like to comment on something like that, because if there is a change, if these bacteria have changed and now they have mutated and therefore are resistant to our antibiotics, have they actually evolved?
Well, they've changed, but that doesn't mean they've changed into another type of bacterium. And in fact, they are still classified as the same species of bacteria. They're just variant number, however many you like to have. The interesting thing about those ones that are resistant because of mutation is that they tend not to exist to cope very well out in the normal environment. That they will grow in the laboratory in under very controlled conditions. So out in the environment, they tend to die off. But the point that is being made in this question is about natural selection and evolution. Those two things are not the same. Natural selection is a real process. Selection simply means to choose between existing alternative. That's going on all the time. The example about the ash dieback and the resistant trees is one of them. Most antibiotic resistance is exactly that. The organisms that already have the ability to resist the antibiotics are the ones that survive and thrive. And so in a place like a hospital where you've got really intense selection because of high levels of antibiotics, yes, that's natural selection in action. It's a normal biological process in this fallen world that we live in. But the bacteria are not evolving. The trees and the fungi are not evolving because they are not changing from one kind into another. So natural selection is a real biological process. It is just a sorting out process. It results in some things dying off and some things surviving and thriving in a particular environment. So don't get those two things confused.
Yeah, thanks, Diane. That's a key point there. To give you a couple of examples, because several times I've said I spent 3 years studying genetics and 1 year actually investigating the chromosomal strands of Drosophila melanogaster. And if you want to go mad from looking down microscopes and sorting out all of these chromosomes, that's one way to do it. But in reality, we had a professor who was very interested in all of this. So we also looked at the evolution of T4 phages, the things involved in tobacco diseases, and you discovered that if it started as a T4 phage, it ended as a T4 phage. These are viral sort of components, and likewise influenza A. If you want to go bored stupid, look at all the variations of influenza A we've got, and over the 70 years they did the study, millions and millions, because this is what it was for. If we are looking at the evolution of man, you got to waste 20 years waiting for the next generation. Yep. Let's take let's take bacteria where they multiply really fast. And if you want to be bored stupid, look at all of the millions and millions of bacteria or the millions and millions of virus even faster. And T4 and influenza A have turned into influenza A. Natural selection for sure, but not evolution. Change, yes, but not evolution. If you're looking at any sort of change in these, it's a downhill change. Yeah. And tragically, this is one of the things that causes disease, because you're used to the one that you get along with. Anything that busts its outside and you can no longer recognize it, you may end up with a disease, unless, like the ash tree, you already proved to have resistance to COVID or something like that. It's almost inevitably in the population. It's just not triggered till you show. And Diane, the line that you make, we didn't discover about these things because we weren't asking what bad things, what good things do bacteria do, correct?
Yes, that's right. And in fact, the same thing applies to resistant bacteria. When they've done studies of bacteria that they found, thousands of miles away from the nearest hospital, like in the forests of Canada or deep down in caves, they have found within that population the resistant genes are already there. All that natural selection does, or in the case of medically acquired antibiotic resistance, it's unnatural selection, but it is selection. You are selecting something that is already there, and it's just being concentrated to the point where it becomes a problem.
Yeah, I remember our professor pointing out one study where they'd actually got, the old-fashioned test tube type things they had in the 1600s, and they'd sealed them and put soil in them. Obviously, someone forgot about them. They refound them, 1920s, 30s, 40s, 50s, right up to today, and tested them. And the bacteria in those soils, yes, reactivate them. They already had penicillin resistance, right? It was there right from the start.
Yes, and so it does have a function, and we have written about a few of those studies in the fact file. If you look up antibiotic resistance, there you'll find some of those, particularly about either old soils or in places that are a long way from any sites where antibiotics were being used.
Yeah.
So your point is this is a loss of genetic information, not a creation of new genetic information. And one of the chatters asked, but don't we see mutations in bacteria? Well, yes, you do see mutations, but as Joe said, that is a downward spiral. The geneticists, all find that mutations are always bad.
And sometimes,
create
well,
something new.
Yeah, well, it's certainly mutations are always a loss of information. They're not a gain of information. You see, in some bacteria populations, the antibiotic resistance comes from the fact that the bacteria have mutated. As a result, they are misshapen or they do not have a particular feature, which means that the antibiotics cannot take a hold and damage the bacteria. Now, you might think, oh, great, it's now, evolved bacteria, it's evolved resistance. Now, it's lost a piece of information due to a mutation. It's now resistant to the antibiotic, but guess what? It's an overall weakened bacteria. It's not actually as healthy as the ones that are resistant. So you're always dealing with a loss of information, and any benefit to the creature or the organism is always only circumstantial. It's a bit like the beetles that thrive on the windy island in the North Atlantic only because they've lost their ability to fly. It's not that they've evolved to live on the island. It's the fact that they're the last ones able to live on the island because all the other beetles have been blown away. So it's a circumstantial benefit as opposed to let's evolve this in order to survive here kind of benefit.
It's pretty well recognised amongst scientists as well. It's pretty well recognised. I worked with probably Tasmania's leading botanist, and his comment on natural selection to me was that it was always a process of specialisation that leads to ultimately extinction. If it goes far enough.
One funny comment to finish this section off. When you look at Australia, we have an interesting history of flies flies are just about anywhere in Australia, and the flies in New South Wales and Victoria are the stupidest flies you could ever imagine because they just hover around and settle on you, and you can almost kill them by hand. But we have other flies that are quite fast, and so they invented surface sprays. But we had a real problem with our surface sprays, which are supposed to be absorbed by the feet of the fly, etc., as it walks across the surface. Technically not supposed to be absorbed by you, but I wouldn't push it too far to test that on your skin. But the reality is we found that the surface sprays were not very effective on Australian flies. Now, it wasn't their accent. It wasn't where they were born. It was the fact that they had the thickest soles of their feet on the planet, right? They were a whole group of these flies whose feet were much thicker than other flies. And I had to giggle at that because being of Scottish ancestry and talk to about my own people and how come they ended up in Scotland, I discovered one interesting factor. Not only did my father say we lived way up north because it was far, we could run from the British, right? And there is a truth in that. But if you wonder, how did these barefooted Scotsmen actually get right up to the top where it's freezing cold? It turns out we Scots have the thickest sole feet of all the people on the planet, right? So we can run across the sharp rocks, and it really is true. So these are natural variants. They're not something the Scots evolved. They're probably the fact that, hey, why are you stuck back there? Why has he been killed by the British? He's got thin-skinned feet, and that eliminated the people who couldn't run across the rocks. In the same way as the movie says, white men can't jump, right? The people who can jump were those who could run fastest and jump highest to get away from the slave traders. So natural selection is very real, but it does not make things, it eliminates them. So the point that Craig made was very good. Natural selection ultimately leads to extinction.